Video signals. When you capture an output, the type of video signal you use to connect your equipment is a critical factor that goes into determining the quality of your video. Video camcorders, decks and monitors can use different types of signals depending on the environment they are intended for. Consumer equipment usually has limited video signal choices. Professional equipment gives you the greatest range of options. Here are the most common video signals used on today's video devices. Composite video. Initially, video contained only grayscale information, that is, black and white. While color broadcasts were being developed, attempts were made to transmit color video using analog RGB, red, green, blue data. However, this technique occupied 3 into more bandwidth than the current grayscale solution, so alternate methods were developed that led to the using Y, RY and GY data to represent color information. A technique was then developed to transmit this Y, RY and GY information using one signal instead of 3 separate signals and in the same bandwidth as the original grayscale video signal. This composite video signal is what the NTSC, PAL and CCAM video standards are still based on today. As the name suggests, composite video is composed of everything required to make up a video. It has the basic black and white picture information, luminance or luma, along with the color information, chrominance or chroma, as well as the timing information sync. It is the most basic and simplest form of video signal. Composite is the lowest common denominator of video signals. A composite signal runs all color and brightness information on a single cable, resulting in lower quality video compared to the quality of other formats. Nearly all video devices have a composite input and output. This format uses a single RCA or BNC connector. In professional editing environments, composite video signals are most commonly used for troubleshooting, for menu outputs and for low-quality preview monitoring. For consumer and home use, composite signals are often used to connect VCRs or DVD players to televisions. A TV or projector needs to separate the various bits of picture information, luma, chroma and sync in order to recreate the picture, and this is a problem with composite video. It is impossible to separate all the information back to the original quality once it has been mixed together in the one cable. This means the picture is not as crisp and the colors not as defined as they could be. S-video, short for super video, a technology for transmitting video signals over a cable by dividing the video information into 2 separate signals, one for color called chrominance and the other for brightness called luminance. When sent to a television, this produces sharper images than composite video, where the video information is transmitted as a single signal over one wire. This is because televisions are designed to display separate luminance Y and chrominance C signals. To use S-video, the device sending the signals must support S-video output and the device receiving the signals must have an S-video jack. Component video, a high-end video interface that supersedes both composite video and S-video. Component video offers better signal clarity, which results in better picture quality. Component video cables have 3 RCA cables, one green, one red and one blue. Component video is an analog format that carries visual data only, meaning audio cables are still required. Professional video equipment such as Betacam SP decks has component YUV video inputs and outputs. Component YUV separates color and brightness information into 3 signals, which keeps the color quality more accurate than that of other systems. Component YUV is as good as analog video gets. High-end consumer devices such as DVD players and televisions have increasingly begun to support component YUV. Another form of component video, component RGB, is not as widespread on professional equipment as component YUV. SCART. The popular SCART interface includes 3 separate RGB channels together with composite and stereo sound signals, with the connected devices choosing the most appropriate video connection. A SCART connector has multiple pins that run composite, component RGB and stereo audio in one bundle. SCART input or output can be broken up into individual connections using special adapters available from video and home electronic stores. Digital video. Analog video signals degrade when material is recorded or distributed. To overcome this, digital signals are now used throughout broadcasting. Another important advantage of digital signals is that massive compression is possible. CCIR 601 or 4:2:2. CCIR 601 was one of the first high-quality digital standards to be introduced. It is also known as 4:2:2 or YCRCB. It comprises luminance Y and 2 chrominance components CR and CB, but as it requires a wide bandwidth for transmission, around 166 megabit per second, it is rarely found outside broadcast studio environments. 4:2:0. To reduce the required bandwidth and thus cost, other formats were developed including 4:2:0. This has the same picture rate and luminance resolution as 4:2:2, but a reduced color resolution which is imperceptible to human eyes, as the human eye is much more sensitive to the luminance signal than to chrominance signal. It is important as it forms the basis for MPEG-2, a video compression standard form of coding used extensively for distributing digital television including Sky and Freeview. SIF and CIF. For less demanding applications, SIF, Source Intermediate Format, was introduced. This has reduced frame rate and chrominance resolutions. An even lower quality format, CIF, Common Intermediate Format, which is a cross between the US and UK SIF formats, is used in video conferencing. Other formats found in video conferencing include the quarter QCIF, 4:CIF and 16CIF for still images. QCIF has the lowest resolution and frame rate and is the baseline format used within IP and ISDN conferencing for compatibility. A big advantage of CIF and its derivatives is that they are independent of origination television standards, PAL, NTSC, etc.